What if the dark, dirty motor oil drained from your car during an oil change wasn't just waste, but potential fuel? Imagine pouring used engine oil into a machine and getting gasoline back out. It sounds almost like alchemy, turning sludge into something that can power a car. But this isn't science fiction. In fact, scientists and engineers have been exploring ways to convert used oil into usable fuels for decades. The real question is not whether it's theoretically possible, but whether used oil can actually be turned into gas in a practical, economical, and safe way. And the answer is far more fascinating than most people realize. Let's explore, right here, on History of Simple Things. Used oil, especially used motor oil, may look ruined, but it doesn't stop being oil just because it has been used in an engine. During operation, motor oil becomes contaminated with dirt, metal particles, water, fuel residues, and chemical byproducts from combustion. It degrades, loses some of its protective qualities, and turns black, but much of its hydrocarbon structure remains. That's important because gasoline is also made from hydrocarbons. In a sense, used oil still contains the molecular building blocks needed to make fuel. The challenge is separating the useful material from the contaminants and reshaping those hydrocarbon chains into something closer to gasoline. One method already used around the world is re-refining. This process cleans and restores used motor oil so it can become lubricating oil again rather than fuel. It removes impurities through dehydration, vacuum distillation, and hydro-treating. But if the goal is to make gas or gas-like fuels, engineers often look at a different process called pyrolysis. Pyrolysis involves heating used oil to very high temperatures in the absence of oxygen. Without oxygen, the oil doesn't burn. Instead, its long hydrocarbon molecules break apart into shorter chains. Some of those shorter chains can resemble the hydrocarbons found in gasoline, diesel, or other fuels. In simple terms, heat cracks the used oil into smaller, more useful fuel molecules. This is closely related to a process used in petroleum refineries called catalytic cracking. Refineries have long used heat and catalysts to break heavy crude oil into lighter products like gasoline. Similar principles can be applied to waste oil. In some experimental and industrial systems, used oil can be processed into synthetic fuel, including gasoline-range products. Some small-scale setups have even demonstrated turning waste oil into liquid fuels that can run engines after additional refining. So yes, used oil can be turned into gas, at least technically. But there's a big difference between producing something gasoline-like in a controlled process and creating commercial-grade gasoline that meets strict standards for modern engines. That's where complexity enters the story. Gasoline isn't just a random mix of hydrocarbons. It has carefully controlled properties such as octane rating, volatility, and chemical stability. Modern engines depend on these specifications. Fuel produced from used oil through pyrolysis may need significant upgrading before it can perform like standard gasoline. It may contain unwanted compounds like sulfur or residues that could damage engines or increase emissions. That means extra refining steps are often necessary, which adds cost and technical difficulty. Turning used oil into true pump-grade gasoline is possible, but it is far from as simple as heating it in a backyard machine. In many cases, used oil is more often converted into diesel-like fuels or industrial burner fuels than gasoline specifically. That's partly because heavier fuel fractions can be easier to produce and use. Some waste-to-fuel plants focus on making marine fuel, heating fuel, or diesel substitutes from used lubricants. Others may blend processed waste oil-derived fuels into broader fuel streams. This can make more economic sense than trying to produce pure gasoline. Still, the chemistry proves that used oil is not necessarily the end of the line. It can be part of a second life as energy. There's also a major environmental reason this matters. Improperly dumped used oil can be highly polluting. A single gallon of used motor oil can contaminate enormous amounts of water. Recycling or converting it into usable products keeps hazardous waste out of the environment while recovering value from something people often treat as garbage. In a world increasingly focused on circular economies, where waste becomes resource, used oil-to-fuel technologies fit right into that vision. Instead of extracting more crude from the ground, why not recover energy from material we've already produced? But there are limits. Converting used oil into fuel takes energy, equipment, and emissions controls. If the process consumes too much energy or creates harmful pollution, the environmental benefits can shrink. Economics also matters. If crude oil prices are low, making gasoline from used oil may struggle to compete. That's one reason large-scale adoption has been uneven. The science works, but the business case depends heavily on technology, regulation, and market conditions. So, can used oil be turned into gas? Yes. Through processes like pyrolysis and catalytic cracking, used oil can be converted into gasoline-range hydrocarbons, and in some cases refined into usable fuel. But the process is complex, expensive, and often more practical for producing other fuels rather than the same gasoline you buy at the pump. Still, the fact that dirty black waste oil can be chemically transformed back into energy is remarkable. What looks like useless sludge may still hold untapped power. And that raises an even bigger question. If we can turn waste oil into fuel, what other trash have we been throwing away that could actually be tomorrow's energy source? Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.